All right, folks, welcome back. We've completed our first pass through the iterative part of the algorithm. That was steps 5 through 11 in the 12-step Szabo process. So we're ready to iterate until convergence. If you have the Szabo and Oslin text, you might want to turn to page 431, and we're ready to begin what they call their iteration number 2. But I've got the iteration numbers a little bit off because I want to agree with that table on page 176. But you should see all the numbers in Appendix B in Szabo and Oslin. You should see all those numbers as we go through the iterations here. So let's come back up to step 5. I don't have this very efficiently done, but we'll re-execute steps 5 through 11 again, then we can watch the values. Notice our G matrix now is not 0. Our G matrix is an updated value as it should be here. It's a much better value as we get closer and closer to convergence. So it's good now to see a non-zero effective electron contribution here. Calculate a new Fock matrix. Just go through the processes here. Again, do the transformation, calculate the C1, C2 values in both bases. And finally, we're up to step 11 again. And now we should be agreeing with the table on page 176. We're iteration 1, our p-value 1.7266, 0.2599 for the off-diagonal pieces, 0.039, and then our electronic energy negative 4.14. So we're in agreement here with the first row in table 3.5. And we should also be agreeing with the numbers in the appendix B. So there we are, and our error term, our delta term, is now 0.279. It's better than the 0.88 or something we had last time, so it's good, but we're certainly not ready to go. So let's just do it again. We'll come back up here to 5, and we'll re-execute these steps again, and you can see the numbers change a little bit each time as we go through. And finally back to 11 again. Now we're iteration number 2. Our error is 0.029. It's getting our p-values are not changing nearly so much as they were at the beginning. And we should be now caught up to row 2 on table 3.5. These values should line up with that. So we're better, but we're not converged yet, so we'll just do it again, back up to step 5, and re-execute these little pieces, 5, 6, 7, 8, 9, 10, and 11 again. Now we're iteration number 3, and our error is 0023, so that's very, very encouraging. And our energy is getting lower and lower as we do this, but it's not changing a whole lot here. If you look at table 3.5 in Szabo, they go to 6 iterations, so we'll do the same thing. Let's go back up here, and we'll do this 3 more times. That guarantees pretty good convergence. So back up, we'll do our 5, 6, 7, 8, 9, 10. You can see the numbers change there, but not a whole lot. Now for iteration number 4, I'm just keeping an eye here to make sure these values agree with table 3.5 values. It looks good, 1.2864. So great, it's going good. Let's do it again. 5, 6, 7, 8, 9, 10, and 11. See, things aren't changing too much. Our error is getting very small here, our delta values. So, I mean, what that's telling us is delta p is very close to 0 values. It means our as we update our new p isn't much different from our old p. Our new density matrix isn't much different from our old one. So let's do it again. Let's go through and do a iteration 6 here. This should be the bottom line of the table on 176. And there we go. The error is so small it's gone into exponents. Now it's roughly 1 part out of a million here, 9.8 times 10 to the minus 7th. So yeah, we're in pretty good shape here. You know, let's just do one more iteration. This would be one more. This would be an iteration 7 that you don't see in table 3.5. Let's just do it and see what happens. Let's do one more iteration. See, watch these numbers here. They're not changing. We've converged. Things aren't changing here to the number of decimal places that we're displaying these numbers. And our error's gone now to 7 parts out of what, 100 million. So you can see roughly an order of magnitude improvement with each iteration. So that's certainly fine, certainly good. Our electronic energy 4.22753. That's pretty much as good as we're going to get here. So let's stop with that. We'll come back in video 6 and number 6, and we'll look at some things that we can calculate once we achieve convergence. Now we've got good stuff. We can calculate a lot of different things. Some of these things will mean more to chemists than to a math person, but if I found a formula for it, I tried to use it. So we'll do that in the next video. So goody, we converged. So I'll see you in the next video. Bye.